Hello, everyone. Welcome back to my Code to Care video series. This is part 2 where I'm exploring the use case about whether generative AI can automatically fix bugs. In part 1, I sort of explained the context, which is that we wanted to find greater and greater tests for generative AI's potential, as well as the business problem. We, in the software company world, and I know in end user world, we spend a lot of R&D costs, a lot of software engineering costs on fixing bugs. So if GenAI can really help with this task, that would be great productivity for all of us. So a group of folks kind of recognized this problem from Princeton and from University of Chicago, and they built this benchmarking database called Software Engineering Bench, SWE Bench. And what it is a series of problems, basically, to bug fix potentials to test whether GenAI could fix the bugs. So let me describe kind of the structure of this database. So you have, first of all, it has 2,294 issues, 94 bugs that are fixed in this database. And what the data set looks like is on the input, you have the code base. All these code bases are Python code bases, 12 very popular Python GitHub repositories. So these code bases. So this particular benchmarking data set focuses on one language, but the ideas can expand to others. So you have the code base, you have a problem description. So these are all from GitHub. So if you're not familiar with GitHub, this is where open source code lives. And people can report issues in an open source repository, and they put in a problem description and hope that somebody that maintains the repository will fix it. In these 2294 cases, these are the real fixes, the real problem description against the code base that has the problem. And you'll see the real fix. So it has the code base, the problem description, and it has the automated tests. Hey there, I'm just popping in to say that I'd love to hear your comments and feedback on this video. I read all the comments, so let me know what you think. Let me know what suggestions you have for my next video by putting in some comments below the line here. Thanks. All the automated tests that kind of represent this particular repository. And then it has the fix, the real fix that some kind of human developer wrote. It has, and then it has new tests. So when you issue a new fix, you usually add a few tests that validate that fix worked, in addition to running all the automated tests from before to make sure you didn't break anything. Okay, so that is that's what the input data set is for Software Engineering Bench, and there are 2,294 basically issues represented here in this data. And then a little bit more about it. This is from 12 Python repositories, repos called. The average repository size is 3,000 files and 438,000 lines of code. Okay, meaning these are big repositories. It's not like little single script or a couple programs type of thing. These are real, well-used repositories out there, like Django is one of them. Flask is one of them, if you're familiar with the Python world. So big repositories, 500,000 lines of code on average. And then the fixes themselves usually are, actually on average, there's each fix edits 2 files and edits 33 lines of code. Okay, so each of these fixes are just targeted toward just fixing that one bug. So there's not a lot of lines of code, but enough lines of code to sort of make it complicated. So that's what this has: the real fixes, the real code base, the real problem description, and then the task is now, can large language models take this as input, automatically generate a fix have that fix not break anything. So all the automated tests, the existing tests and the new tests work so that we have a fix that's been AI generated that actually does the job. So that was the setup for this data set. And what I'm going to do in my next video is give you a sense for how an LLM fits into this, how generative AI kind of fits into this, and what the performance is to date, and what are the next steps that the industry is pursuing this year. So that's it for this video, and I'll see you on the next video. Thanks. Bye. Hey there. I hope you liked this video. I've added a next video at the end of this, so take a look at that if you enjoyed this. And if something resonated with you, please drop a comment at down below here. I read every comment myself, and I really appreciate hearing from you. Thanks.